Yesterday we looked at shifting periodic functions up and down, and then we stretched them vertically. Today we're going to include horizontal shifts as well as x-axis reflections. Yeah, so for each of these, the periodic functions are infinite. There are an infinite number of periods. We're just going to graph one. So you'll notice both the x-axis and the y-axis are unlabeled. So a regular sine function on the y-axis is bounded between 1 and -1. And you can either label the x-axis in degrees or radians depending on what the horizontal shift is. So this one I'll just label in degrees. Where does the sine function begin? In the center. So on the center line. From the center line to the top, to the center line, to the minimum, back to center. So all of the sine graphs we do today will be based on this one. Am I going too fast? I'll slow down. Oh, I'm calm. Just speedy. Speedily calm. Are we done? Come on, hurry, hurry. Okay. So the cosine graph, if I were to graph it in radians, would be pi over 2, pi, 3 pi over 2, and 2 pi. Cosine is also bounded between 1 and -1. Where does the cosine start? At 1 at the top. So it would be top, middle, bottom, middle, top. And that's just one period. It's going to continue in both directions forever. Okay? So now, if you look at letter C, the sine of theta plus 90. If we change the horizontal axis, everything works backwards from what you would expect. If you're changing the y-axis, multiplying stretches, adding goes up, subtracting goes down. Everything on the horizontal axis is backwards. Multiplying makes it thinner. Adding goes left, and subtracting goes right. So this is the sine of theta plus 90, which shifts everything left 90 degrees. So normally, sine would start at 0 on the midline, but now it's going to be at -90 for the midline. And then it's going to max out at 0 degrees up here at 1. And it's going to come back down and hit this at 90. It's going to minimize at 180. And it's going to be back at the midline at 270. And again, this continues on forever. And if it makes you happy, you can draw arrows or not, whatever. If this afternoon finds you gray, put arrows on the end of your sinusoid. Nope, nope, I'm losing my poetic abilities. So, do you notice anything about this graph? It's just a cosine graph. So the cosine of theta is absolutely equivalent to the sine of theta plus 90. Is there a cosine graph that would be equivalent to a sine graph? What would it be? Cosine of theta. Well, if we shifted the sine to the left, then we'd need to shift the cosine to the right and subtract 90. Okay? Could you graph a cosine, a shifted cosine that looks exactly like a normal cosine? We could add 360 to theta or subtract 360. Pulling it one cycle to the right is the same as pushing it one cycle to the left. So there are actually an infinite number of equivalent periodic functions. Every sine graph can be written as another sine graph or in terms of cosine. Okay? All right. So letter D, cosine of theta minus 180. Which direction is that going to move? To the right. Anything that happens to the theta shifts it right or left. So I don't have a lot of room to the right, so I'm going to make these marks kind of small. First mark is 180. What would the next one be? 270, because there's each critical point has a distance of 90 degrees. And then 360, and then do you want a trick to add by 90? It's really easy. Add 100, subtract 10. 450, good job. Next one, 540. Okay? And we're bounded by 1 and -1. Where does the cosine start? At the top. So it'd be top, middle, bottom, middle, top. It now starts at 180 because it's been shifted to the right. Okay? Letter E. We're going to shift right 25 degrees. And this one's a little bit harder than the others. Not really harder, it's just kind of annoying. So 25. What's the next mark going to be? 115. What's the next mark? 205. And then we were doing this earlier today, and somebody's like 205 plus 100, 305 minus, and I'm like, wait a minute. You're making it harder than it needs to be. 205 plus 90, 295. Sometimes the tricks are a lot harder than the actual arithmetic. And the last one would be 385. So this is a sine graph which starts in the middle, and we're bounded by 1 and -1 again. So middle, top, middle, bottom, middle. And to make yourself happy, put the arrows on it. Okay? Does that make sense to everybody? Okay. For letter F, I want to change that to a plus 45. Yeah. I want to shift it left, not right. So over here at -45, what's the next critical point going to be? 45. And then 135, 225, 315. And this is a sine graph bounded by 1 and -1. Middle, top, middle, or sorry, middle, top, middle, bottom, middle. There we go. Why doesn't it what? No, where are you confused? Well, because the space from here, the first critical point to the other one has to be 90. So it doesn't hit the y-axis at a nice number. It's actually going to be like 0.7 or something. 0.707, if you remember. Root 2 over 2. Okay. G you can handle, H you can handle. Look at I. Now we have to label the theta axis in terms of radians. Which direction did this shift? Left. And it shifted pi over 2. In radians, what is the distance between the critical points? Pi over 2. 90 degrees is equivalent to pi over 2. So my first critical point is -pi over 2. My next one would be 0. There's going to be one at 0 in this case. And then pi over 2. And the next one would be pi. And the last one would be 3 pi over 2. So remember, in order to graph a full period, you need 5 critical points. That's 4 quadrants plus the end point. Or first point, depending on how you look at it. This is a sine graph bounded by 1 and -1. Sine starts in the middle. So middle, top, middle, bottom, middle. perfectly formed sinusoid. Okay. All right. Next one. Are you not done? What? Oh, I'm doing the next one. So, J. Which direction am I moving? Left. We'll get to K. We'll do it. So, we're going to move left to pi, negative pi. What's my next critical point? Negative pi over 2. Now, I keep using this word critical point, and it means what you think it means, those 5 marks that are important. But critical point is actually a calculus term. Critical points are either maximums, minimums, or what we call inflection points. And I'll show you what an inflection point is in just a second. So my next critical point would be 0, and then pi over 2, and pi. So this is a cosine graph, again bounded from 1 to negative 1. Where does the cosine start? At the top, right? Cosine begins at the top. And our first critical point is negative pi, so top, middle, bottom, middle, top. So an inflection point is where the graph changes from what we call concave up to concave down. Yes? So if I were to continue this graph on and on and on, if we were to draw the concavity, which direction it is, here you can see this one, the cave points down, and this one, the cave points up, and in this case, the cave points down. Whenever you switch from down to up or up to down, it's called an inflection point. And inflection points and maximum and minimums are hugely important in calculus. So that's a critical point because it's a maximum, that's a minimum, but both of those are inflection points where it switches from concave down to concave up or vice versa. So that's what I mean when I say critical point. Okay, now what if I were to change the graph of J, and instead of plus pi, I wrote minus pi? How would that affect the graph? Move it to the right, and it would look exactly the same as it does now. So shifting a regular sine or a regular cosine 180 degrees in either direction is going to create the exact same graph. Yeah, so instead of this piece here, we would actually graph this piece here, which is just a continuation. So it's the same graph. All right, letter K. This is kind of tricky. Not really, it's not too bad. Which direction am I shifting? To the right. So this will be pi over 3. How far do I need to move to get to my next critical point? Pi over 2. So really I'm taking 1/3 and adding 1/2, which needs to be done with the denominator of 6. So it would be 2 over 6 plus 3 over 6, which is 5 pi over 6. So my next critical point is 5 pi over 6. How would I reach the one after that? Add another half, also known as 3/6. So I'm going to add 3 over 6, which gives me 8 over 6, also known as 4/3. So 4 pi over 3. How do I find the next one? Add 3/6 to 8/6. 11 pi over 6, also known as 11 pi over 6, doesn't simplify. The next point is going to be 14 pi over 6, also known as 7 pi over 3. And this is a sine graph bounded by 1 and -1. Middle, top, middle, bottom, middle. We getting the hang of this? Okay. I'm going to leave L up for you. Letter M. What is M going to look like? Well, it's not the inverse. It's a reflection, but we have to think, are we reflecting the thetas, the horizontal axis, or are we reflecting the y values? What are we changing here? The y value. So every negative y value becomes a positive y value, and every positive y value becomes a negative y value. Reflecting across the x-axis, right. So the cosine normally would start up here at 1, but the reflection is going to start at -1. So we put those critical points, the cosine is going to look like this. Now you can reflect sines and cosines across the y-axis, but there's really not much point to that. Like, I don't know. I mean, technically you can perform any transformation with or without a reflection. Right? We could have done this by shifting by 180 degrees, right? So we won't ever do a y-axis reflection. There's just really no point. So in a similar vein, n is just going to be a sine that looks like this. So 90, 180, 270, and 360. Now for the fun ones. We're going to combine everything you know so far. Letter O. Describe for me what's happening here. Left 90 and up 2. Does the order matter? If I go up 2 and left 90, is that different than left 90 and up 2? No. Now, there are some transformations that have to be completed in a correct order, but you won't run into any of those today or any other time I give you sines and cosines. So you can perform them in whatever order makes the most sense to you. There is a specific order, but it turns out it doesn't matter in the problems that I'm going to give you. So I'm going to put my new center line up at 2, which means my maximum will be at 3 and my minimum will be at 1. I'm going to shift everything left 90 degrees. So this will be -90, 0, 90, 180, and 270. It's a sine graph, which means it starts in the middle. So middle, top, middle, bottom, middle. Does everybody understand that? Okay. You ready to move on? Good. Letter P. What's happening here? Down 1, right 50 degrees, and it's upside down. So I'm going to put my new center line at -1. My maximum will be at 0, and my minimum will be at -2. I need to shift everything to the right 50. So my first critical point is 50. What's my next one? 140. We'll get there. 230. 320, and one more. 410. Now this is a cosine graph. Where am I going to begin? At the bottom, at -2. Normally it would start 1 above the center line, but because it's negative, it flips upside down and we begin at the bottom. So bottom, middle, top, middle. Wait, did I mess up? Oh yeah, I did. Sorry. Bottom, middle, top, middle, bottom. Everybody okay with that one? Where are you confused? You got it. You're just not happy. No. No, actually the reflection is first. Reflection. Yeah. So I guess the order does matter on that one. So you start with the theta and work out. So technically it's right 50, upside down, down 1. So I lied to you. The order does matter. Start on the inside and work your way out. That's the real order. So the vertical shift is always the last thing that happens. Okay, thanks for pointing that out. You're always bringing my shortcomings to light. Thank you. Okay, what's happening here? 3 times taller. Left 1 or right 1/4 and down 2. So my new center line is down at -2. And my first critical point is pi over 4. How do I find my next critical point? Add 2/4, which is pi over 2, pi halves. So 2/4 would be 3/4 pi. The next one's going to be 5/4 pi. 7 pi over 4. And 11 pi over 4. Where is my maximum? It's 3 times taller, so my maximum is at 1, and my minimum is -5. Oh, yeah. 9 pi over 4 is the last one. Sorry. 13579. Apparently I don't know my arithmetic series, right? Okay. So this is a sine graph, starts in the middle, top, middle, bottom, middle. Now, you can actually graph these in your calculator if you wanted to, but it's a huge hassle because every time it shifts horizontally, you would need to change your window, and if it doesn't shift using the same critical points, like if it shifts 90 degrees, that's nice, but if it shifts like 37 degrees, then you have to recalculate. It's just a mess. So it's much, much easier to just graph them by hand than it is to throw them in the calculator. I mean, the calculator will graph it, but you'd have to change the scale of your x-axis every time it did a horizontal shift, and it's just not worth your time. So graphing it by hand is much easier. All right. Good luck.